Imagine this: everything you've ever known, galaxies, stars, planets, even you, was once smaller than a grain of sand. And then, in less than a second, it expanded into everything. But how can something come from nothing? And what if the story of the universe is even stranger than we think? Welcome back to my channel. Today, we're diving deep into the ultimate origin story, the Big Bang Theory. By the end of this video, you'll understand not just what the Big Bang was, but also how it shaped everything, from the first particles to galaxies to the very atoms in your body. And trust me, stick around because the twists at the end will blow your mind. First, let's clear something up. The Big Bang was not an explosion in space. It was the rapid expansion of space itself. Imagine blowing up a balloon, the surface stretches, and every point moves away from every other point. That's what happened to the universe. It didn't happen at a particular spot in space, and it didn't expand into something. Instead, space itself was born, carrying matter, energy, and time with it. So what actually happened during those first moments? Let's break it down. At time zero, we start with a singularity, an infinitely hot, dense point. Physics as we know it simply stops working here. At 10:32 seconds, a mind-blowing event called cosmic inflation occurs. Space expands faster than the speed of light, stretching from subatomic size to astronomical scales. At 1 second, the universe is now 100 billion kilometers wide. Protons and neutrons form from quarks, and matter finally starts taking shape. At 3 minutes, the first light elements, hydrogen and helium, are born through nuclear fusion. At 380,000 years, the universe cools enough for atoms to form, and light finally breaks free. This is what we now detect as the cosmic microwave background radiation, or CMB. Okay, cool story, but how do we know this is real? Scientists rely on three main pieces of evidence. Cosmic microwave background, CMB. This faint glow of leftover radiation discovered in 1964 is the smoking gun of the Big Bang. Of galaxies discovered by galaxies are racing away from us. The farther they are, the faster they move, proving the universe is still expanding. Abundance of light elements. Hydrogen and helium exist in just the right ratios predicted by Big Bang nucleosynthesis. Now let's bust a few myths. The Big Bang didn't happen in space, it created space. It wasn't an explosion that sent matter flying into emptiness. It was space itself stretching. And no, scientists don't claim we know what caused the Big Bang. That's still one of the greatest mysteries in physics. So in this first part, we've gone from nothing to the creation of space, time, and matter. But this is just the beginning. In part 2, we'll explore how this chaotic universe of particles turned into stars, galaxies, and planets. And the story gets even wilder when we talk about dark matter, black holes, and the fate of the universe. In part 1, we saw how the universe began from almost nothing, expanding faster than light, cooling down, and giving birth to the first atoms. But the story doesn't stop there. Imagine a universe filled with nothing but dark hydrogen gas. No stars, no galaxies, no light, just endless, invisible fog. How did that turn into the beautiful night sky we see today? Let's find out. After the Big Bang, once atoms finally formed, the universe entered a strange period scientists call the cosmic dark ages. For hundreds of millions of years, there were no stars to shine, no galaxies to sparkle, just darkness filled with neutral hydrogen gas. During this time, the universe was slowly expanding and cooling. Gravity was quietly at work, pulling clumps of hydrogen together. Imagine invisible seeds gathering dust and gas, waiting to ignite. Then, around 100 to 200 million years after the Big Bang, something incredible happened. Gas clouds collapsed under gravity and became so dense that nuclear fusion ignited. The first stars, known as population III stars, were born. These stars were monsters. Many were hundreds of times more massive than our sun, burning furiously and dying young. When they exploded as supernovae, they forged heavier elements, carbon, oxygen, iron, and scattered them across the cosmos. Without those first stars, planets, life, and even us could never exist. These first stars didn't form alone. They gathered together into clusters, and over time, gravity pulled those clusters into massive structures, the first galaxies. Some of these early galaxies were small and chaotic, colliding and merging with each other. Others grew into giant spiral galaxies like our own Milky Way. Galaxies became the universe's building blocks, housing billions or even trillions of stars. But here, where it gets weird. Ordinary matter, the stuff that makes you, me, stars, and planets, is only about 5% of the universe. The rest, mostly dark matter. Dark matter doesn't emit light. We can't see it, but we know it's there because of its gravity. Without dark matter, galaxies wouldn't hold together, they'd fly apart. Think of it as the invisible glue of the cosmos. As stars died, many collapsed into black holes. These weren't just cosmic vacuum cleaners, they were architects of the universe. Giant black holes sat at the centers of galaxies, shaping their growth. Our own Milky Way has one, Sagittarius A, a supermassive black hole 4 million times the mass of the Sun. Black holes also power some of the objects in the universe. Quasars, galaxies with supermassive black holes feeding on matter, blasting out energy brighter than trillions of stars combined. But where do planets fit in? As stars exploded and recycled their material, heavier elements like silicon, iron, and carbon spread into space. New generations of stars formed with these elements, and around them, planets began to take shape. Around one such star, our Sun, a small rocky planet formed. And billions of years later, it became home to oceans, forests, civilizations, and you watching this video. So from the quiet darkness after the Big Bang, the universe blossomed with stars, galaxies, black holes, and planets. But the story doesn't end with creation. Because even now, billions of years later, the universe is still expanding, and here's the kicker. It's not slowing down, it's actually accelerating. In Part 3, we'll explore the greatest mysteries still unsolved. What caused the Big Bang, what came before it, and how the universe might end. Will it expand forever, collapse in a big crunch, or tear itself apart in a big rip? The answers, or the questions, will surprise you. So far, we've seen the universe born from the Big Bang, watched it transform from particles into stars and galaxies, and discovered how black holes and dark matter shaped everything we know. But the Big Bang story isn't finished. In fact, the most mind-blowing parts are still ahead, because there are questions science can't yet answer. Questions about the beginning, the end, and whether our universe is just one of many. Let's start with the biggest mystery: what caused the Big Bang? Science explains what happened after the bang, but the very first instant remains a mystery. Was it a quantum fluctuation, an event where tiny particles randomly appear from nothing, only this time on a cosmic scale? Was it the collapse of a previous universe, reborn in a new cycle? Or was it something beyond physics as we know it? Right now, we simply don't know. Our best theories, like quantum mechanics and relativity, break down when pushed to that limit. To solve it, we'd need a theory of everything, a framework that unites the very large and the very small. Scientists are chasing this with ideas like string theory or loop quantum gravity, but the truth remains out of reach. And that leads to another haunting question: what came before the Big Bang? Some scientists argue this is a meaningless question, because time itself began with the Big Bang. Asking what came before is like asking what's north of the North Pole. But others believe there could have been something before, maybe another universe, maybe an eternal cycle of expansion and collapse, or maybe even a multiverse, where infinite universes are born like bubbles in a cosmic ocean. If that's true, then our universe may just be one tiny chapter in a much bigger story. Now let's talk about the future. We know the universe is expanding. But in the late 1990s, astronomers made a shocking discovery. The expansion isn't slowing down, it's speeding up. Something is pushing galaxies apart faster and faster. We call this force dark energy, and it makes up nearly 70% of the universe. But here's the kicker: we have no idea what it actually is. It could be a property of space itself, or some new kind of energy field we've never seen. Whatever it is, it's rewriting the fate of the universe. So how will it all end? Scientists have three main scenarios. The Big Freeze, or heat death. If expansion keeps accelerating, galaxies will drift so far apart that night skis will go dark. Stars will burn out, black holes will evaporate, and the universe will become a cold, lifeless void. The Big Crunch. If gravity someday overpowers expansion, the universe could reverse, collapsing back in on itself into a final singularity, the opposite of the Big Bang. The Big Rip. If dark energy grows stronger over time, expansion will accelerate so much that galaxies, stars, planets, and even atoms will eventually be ripped apart. Which one will happen? Right now, the evidence leans toward the Big Freeze, but the universe is full of surprises, and dark energy is still one of the greatest unknowns. But what if the Big Bang wasn't the only answer? Some scientists suggest alternate theories. Steady-state theory. Once popular, it claimed the universe has always existed, with matter continuously created as it expands. It's largely disproven but fascinating historically. Cyclic universe, a never-ending loop of big bangs and big crunches. Simulation hypothesis. What if the universe is not physical at all, but a simulation? If so, the Big Bang could have been just the boot-up moment. While these ideas sound wild, science thrives on asking bold questions. So why should you care about the Big Bang? Because it's not just the story of the universe, it's your story too. The iron in your blood, the calcium in your bones, the oxygen you breathe, all forged in stars that exploded billions of years ago. You are literally made of stardust. The Big Bang isn't just a theory about the past, it's a reminder that we are deeply connected to the cosmos. Understanding where we came from helps us ask the biggest question of all: what comes next? The Big Bang gave birth to everything: space, time, matter, and life itself. And yet so much remains unknown. What caused it? What came before? How will it all end? Maybe we'll discover the answers, or maybe the mystery is what keeps us looking up at the stars. If you enjoyed this journey through time and space, don't forget to hit that like button, subscribe for more mind-expanding videos, and share your thoughts in the comments. Which theory of the universe's fate do you believe in? The Big Freeze, the Big Crunch, or the Big Rip? Until next time, keep wondering, keep exploring, and remember, you are part of the universe's story.